Where, to the Padhai channel, you can practice more problems on this exact topic on our Padhai Karlo Android app. Link in the description below, or build below, or our website padhaikarlo.com. Today's topic is conformations of Na and butane, and how to read and draw Newman projections. Let's begin. A Newman projection is genuinely a way of drawing a molecule while looking straight down one specific carbon-carbon bond. The front carbon is drawn as a simple dot with 3 lines radiating out, and the back carbon is drawn as a circle with 3 lines coming out from behind it. Rotating around a single carbon-carbon bond genuinely costs almost no energy, since it's a sigma bond, and this free rotation genuinely produces infinitely many possible arrangements called conformations, which are not different compounds, just different temporary shapes of the exact same molecule. For Na specifically, the eclipsed conformation, where front and back hydrogens directly overlap when viewed down the bond, is genuinely the higher energy, less stable arrangement, because of the electron-electron repulsion, called torsional strain, between the eclipsed bonds, while the staggered conformation, where the back hydrogens sit exactly between the front ones, is genuinely the lower energy, more stable arrangement. Here Chlois thermal Pesahissing Paschimi Afriki Rendinavian Leone carbon now carries a bulky methyl group instead of just a hydrogen, rotating around the central carbon-carbon bond of butane genuinely produces FOUR distinct conformations worth naming specifically. The anti-conformation, with the 2 methyl groups pointing in exactly opposite directions, 180 degrees apart, is genuinely the most stable of all, since the 2 bulky groups are as far apart as possible. The gauche conformation, with the 2 methyl groups 60 degrees apart, is genuinely somewhat less stable due to steric strain, the physical crowding between the 2 nearby methyl groups. The fully eclipsed conformation, with the 2 methyl groups directly overlapping, is genuinely the least stable of all, combining both torsional strain and the worst possible steric strain simultaneously. The single most frequently tested G skill here is genuinely reading a Newman projection directly and identifying whether it shows the staggered or eclipsed arrangement, and specifically for butane, whether it's the anti-gauche or fully eclipsed conformation, based purely on the angle between the 2 largest groups shown. A frequently tested trap involves genuinely remembering that conformations are not isomers, since they interconvert freely at room temperature through simple bond rotation, requiring no bonds to break at all. This is fundamentally different from constitutional or geometric isomers, which genuinely cannot interconvert without breaking bonds. Also remember that a potential energy versus rotation angle graph for butane genuinely shows the anti-conformation at the lowest point of the curve, with the fully eclipsed methyl-methyl arrangement at the highest peak, and the 2 gauche and 2 pure Chlois thermal Pesahissing Paschimi Afriki Rendinavian Leone falling at intermediate energy levels in between. Let's recap. A Newman projection views a molecule down 1 cc bond, front carbon as a dot, back carbon as a circle. Ethane's staggered form is more stable than its eclipsed form due to torsional strain. Butane adds steric strain from its methyl groups, giving 4 conformations, with anti as the most stable, when the methyls sit 180 degrees apart, gauche as intermediate, and the fully eclipsed methyl-methyl form as least stable. Conformations interconvert freely and are not isomers. Reading Newman projections and ranking stability are the key skills this topic tests. That's conformations of Na and butane. Keep the anti-gauche eclipsed stability order sharp. It's the fastest way to answer Newman projection questions on the exam. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.